So today is the second half of primes, which is prime factorization. So there's two vocab words, again, find your vocab section. The first is a factor tree, which I didn't really know how to define in words, so I just drew a picture of it. So a factor tree is when you start with a number and you create branches based on what multiplies to that number. So for example, you could pick 2 and 6 or 3 and 4. 1 and 12 is not helpful. What we are trying to do is find the prime numbers that go into 12. And remember, 1 is not prime. So I chose 2 and 6. 2 is prime, so we are done with that branch of the factor tree. And we continue factoring 6. 6 is 2 times 3, which are both prime. So we are done with our factor tree. We use the factor tree to write numbers as prime factors or in prime factorization form. So prime factorization is when a number is written as a product. Remember, if you don't remember what product means, it means multiplication. So the answer to a multiplication problem of primes. So looking at our example of 12, we had 2 times 2 times 3, which is another way to write this. I typically simplify my prime factorization by using exponents anytime a prime factor is repeated, so 2 squared times 3. Start a new sheet of notes, make sure you have it in Cornell style. Label learning target number 2, day 2. Our objective today is I can write the prime factorization of numbers and expressions, so we're going to be looking at those variables again too. So our first section is just focusing on numbers. Our first number is 36. So I'm going to start with my factor tree. There are several different numbers that multiply to 36. The first ones that jump out at me are 6, 6 times 6, and 6 is 2 times 3. So this would be 2 times 2 times 3 times 3, or as I prefer using exponents, 2 squared times 3 squared. Let's take a look at the prime factorization of 75. The first numbers that jump out at me that multiply to 75 are 3 times 25. 3 is prime, 25 is 5 times 5. So we could write this as 3 times 5 times 5, or 3 times 5 squared. Now we're going to take a look at how to write the prime factorization of expressions. So we're going to start with the number, and that factor tree looks the same as the other ones. 24, 3 times 8, 8 is 2 times 4, and 4 is 2 times 2. Looking at the variables, x squared, I'm going to do the factor tree upside down, don't have a lot of room below, is x times x. Y, remember, is prime, it's a variable by itself with no exponent, and z to the fifth is z times z times z times z times z. So to write the prime factorization of this whole expression, it would look like 2 cubed times 3. And because I like to use exponents when I use the prime factorization, you really could leave it as x squared times y times z to the fifth. But since you're just getting used to this and knowing where I want you to go with this in the next lesson, I'm going to have you write the variables out the long way. That way it tells me you know what those exponents mean for variables. I'm a little more comfortable with you knowing what exponents mean for numbers. Alright, so our next expression, 51. You might be thinking 51 is prime, but 5 plus 1 is 6. And remember, that was one of our shortcuts for our divisibility rules. Because 5 plus 1 is 6, and 6 is divisible by 3, 3 goes into 51. If you don't know how many times 3 goes into 51, use your brain and long division, and you should get 17. 17 is prime, so writing this out, we would have 3 times 17. A cubed is a times a times a, and b